Hey everybody, welcome to Investigating Odometers. Today you're going to be using a measuring tape and your code.Node and your code.Node cart. But first, let's talk a little bit about how odometers work on your vehicle. An odometer is an instrument that measures the distance a vehicle has traveled. You may have heard somebody in your family talk about how many miles are on their vehicle or how many miles they've had to travel. Most odometers calculate the distance a vehicle has traveled based on the number of wheel rotations times the tire circumference, which is the standard tire diameter times pi. All right, so I gave you a lot of information. Essentially what we're saying is an odometer works by counting a full rotation of the tire, and that's how it's calculating distance. It's taking the circumference of your tire and how many rotations you are traveling. In this activity, you're going to have to be working with circumference, so you may or may not have been introduced to the formula, so let's have a quick discussion about it. So calculating circumference is going to be 2 pi times radius, or it can be calculated with just pi times the diameter. And let me give you an example of that math. All right, so say you have a vehicle that has a tire with a diameter of 50 millimeters. You're then going to multiply that number by 3.14, which is pi. In this case, it gives us 157 millimeters. In this activity, we're going to be working with a meter tape, so why don't we try converting that to meters? And to do that, you simply take 157 millimeters, 157 millimeters, and divide that by 1,000, and that gives us 0.157 meters. All right, so now we have the circumference of a tire. How does that calculate to distance? Well, here's the formula for that. So say I know that the circumference of my tire wheel is 0.157 meters. If I want to know how far that vehicle has gone, let's say it's a toy car, because these are pretty small measurements. If it's gone 2.3 rotations, that's saying that the car has traveled 0.36 meters. So why are we talking about this? Well, you're going to put this into play today and create a Blockly program that indicates every time you make a rotation, and then we're going to take it a step further and create a function in which you're going to calculate how many rotations you've taken over a certain distance. Let's talk about the engineering in this vehicle, because it's pretty cool. The code.Node cart can calculate distance and cart position, cart velocity, all based on a magnetic field sensor, which is in the code.Node. And it works along with this device. I'm going to play this video for you so you can see this in action. You see in the back here on the axle, as I spin that, you see a little plastic piece. That's actually a bar magnet. So with every half turn of that wheel, you're going to have a half a rotation. And a full rotation, 360 degrees, is going to be a full rotation. I'll play that again. Pretty neat engineering, don't you think? All right, so let's get to coding. All right, I want you to see how the magnetic field sensor works with these rotations. So the first thing I want you to do, we're going to disengage the temperature, light, and sound sensor. We won't need that for this. And I'm just going to check the magnetic field strength sensor and disable the others. And pull up a line graph. All right, so you see we have a graph of magnetic field strength over time. If you look at the bottom left hand of the SparkView screen, that's a live data bar. So we're going to be measuring magnetic field strength in Gauss. For this activity, it's going to be really important whenever you start your vehicle calculations to get it as close to 0 Gauss as you can. So see how I move the vehicle slightly. I'm getting closer to 0 Gauss. Doesn't have to be perfect, just close. All right, and then I'm going to click Start and watch what happens. So see, as I move the vehicle, when I get those peaks, it's showing me the rotations of the wheel. So if we're just looking at this one right here, guys, that's only a 180 degree turn of that axle that I showed you before with the bar magnet. And then it peaks up here, that's a full rotation. Pretty neat data. Let me show you why it's important to always start at that 0 Gauss again, because you want to try and replicate your data as close as possible. All right, I'm almost there. And start again. And let's put one run over the other so you can see. That's why it's really important that you try and start as close to 0 Gauss every time you can. Okay, so now you're going to have a Blockly challenge where you're going to use Blockly and the code node and the cart, and you are going to try to devise a program in which your vehicle lets you know every time you've made a rotation. So you will have to use magnetic force in this program. So those pretty much are just your parameters. So I'm going to have you pause the video and try and work through this. Okay, everybody, let's see how you did. I'm sure you came up with great programs, but I'm going to model one for you. You might have done something different, which is great about coding. So I am going to click on the code icon since I'm already connected to SparkView. And let's start with a repeat while true loop. Pull that over. And I'm going to pull in a conditional block, and I'm going to have it say, if the magnetic field strength is greater than 1, it's going to cause the speaker to go off. So I need to go on hardware again, pull that out. I'm going to put this at 1,000 Hertz so you guys can hear. And I'm going to put in a little sleep timer. And this is why. So I've set it, if it's over 1 Gauss, the alarm's going to go off. But I need it to also do the opposite. So I'm going to duplicate this whole section. You could pull them out one by one if you wanted. I'm just going to pick the whole thing and give it another conditional. But now, if it is less than 1 Gauss, it's not going to do anything. Let me bring you back to the data screen so you can see why I chose these numbers. So look at the graph. I know one rotation positive here, another half rotation negative. So essentially my program is saying every time you see one of these peaks up here, my code node cart's going to beep. And I can kind of count that as a rotation. It's not exact mathematics, but it's pretty close, and it gives you a great idea on how an odometer may work. So let's see how it works. All right, I'm going to press start. Again, I'm going to go back to my code to see that I can get close to 0 Gauss. That's close enough. And hit start. So you noticed every time it hit top peak, positive integer over 1 Gauss, I got a beep. Pretty cool. Hopefully you were able to do something similar. Now we're going to take it a step further, and we're going to talk about that distance piece. So you earlier in this activity, which you can access through the digital book or through the student activity sheet that you might have a hard copy of, you are charged with finding the circumference of this actual code node cart wheel and plug that into a formula. I'm going to build the program with you because you do have it step-by-step directions in your activity, but I'm going to leave out one piece. So let's get going. Okay, so I'm going to start a new experiment because I need a couple extra measurements to get my program to work here. Again, I'm referring to the student sheet that you have as well to do this. It's a more advanced program because you're going to actually be creating a mathematical function. I'm going to choose sensor data. My code node's already attached. I'm going to disable temperature, light, and sound. You don't need those. I'm going to leave magnetic strength. And then I'm also going to want cart position. So I'm going to leave this, and disengage the buttons and go to the graph. Then just go down to the code icon and let's start building your function. So I'm going to go here to the functions tab and pull the top one out, and I'm going to name that number of rotations. I'm putting spaces into my program here. You may not do that. You may choose to. Either way, your program will work. Then I need to create a variable. Click on that, and I'm going to name this full rotation. All right, so within this function, I want to set a full rotation to the cart position, which in this case is going to be distance traveled. And I need to put this actually in a math bracket. So let's pull that out. I'm going to make this a little bit bigger so you can see. My cart position divided by, and for now I'm going to put 0, because what's going to go in that spot is the circumference of the cartwheel tire that you calculated yourself. I'm not going to give you that. So there's my function. So now let's build the rest of the program. I am going to create a loop while, and this is kind of an interesting piece. This is why it kind of bumps up the complexity of the program. I want to set from the very beginning a full rotation to 0. That's just making sure that we're starting at 0. And I'm going to pull out a comparison block, and I'm going to say while the cart velocity, so that's the speed it's traveling in a certain distance, drop down menu to get to that, cart velocity is greater than 0. So as long as it's moving, set that to 0. Then let's pull in our function. Number of rotations. And here's a piece you may not have done yet. We're going to create a numerical output, something that we're going to see on the screen. So I need to choose code output, create numeric output. I'm going to name that rotation, so it's easy to refer to, and pull that in underneath. And this is where we're going to recall that variable again, a full rotation. All right, so there's our program. I'm going to do one more thing. I'm going to go back and click the code and add a page, because I want to see a couple things. I'm going to choose the 2-page template, and on this side I want to have magnetic field strength over time so you can see peaks. Here I'm just going to click on the digits, but on select measurement I want user entered. That's that output of numerical output that you created earlier. And I named it rotation so I could find it easily. There we go. All right, well, I'm not going to let you see yet, but I'm going to plug in the number I got for the circumference of the wheel. And check this out. Remember, we start as close to 0 as possible. I'm going to click start, and I'm going to roll the cart 1/2 meter. Check it out. So it's saying that the cart went about 4.74 rotations. So a little less than 5 full rotations of this wheel occurred in the distance that I pushed. And you're very close because you can compare that rotation to your magnetic field strength data. Pretty cool program. All right, well, good luck with that, guys. Hope you get your circumference calculation correct. Good luck.